First of all, thank you, Professor Amoto, invite me to give this talk. And in this time, my talk, the title is DNA nano-assembly for the application in cancer diagnosis and therapy. Sorry. Okay, with the continued development of modern science and technology, although the human being has made a great progress in medical.
Professor,
okay, you can
speak it. Shared.
Now you can listen to my talk.
Yeah, we can listen to you, but there is no present. Like you didn't share your screen.
It did not show.
No, it did not show. No.
Yeah, okay.
Do you see the green button when where it says share screen? There's a green button in the middle. It says share screen.
Jun-Jie, you listen to me. This is Amato.
No, it's okay.
So
Let me share the screen.
You have a
more.
Yeah, now is good. You can continue your presentation, please.
Yeah. Can you see the screen? Is it okay?
Yes, we can. Yes.
Okay. Okay. I continue to report my work. With the continued development of modern science and technology, although the human being has made great progress in medical research and research construction disease, the construction in disease still threatening human health, especially the cancer, which is the primary cause of the health disease. It has been reported that only preventions, only diagnosis, and only the treatment are important to improve the care rate of cancer patients. So it is important to only prevention, diagnosis, and treatment. In terms of the cancer treatment, nanoparticles are widely used in the construction of cancer treatment performance. However, this drug delivery platform suffer from significant cytotoxicity and immune response challenges due to the long-term use of materials. In addition, the non-specific and complex preparation processes of this material are also greatly limited their further clinical application. This is the background. So it is very important to find the method to drug recognition. As a biological substance, the DNA has attracted attention of many biomedical research because of its excellent solubility, biocompatibilities, and functionalization. With development of DNA nanotechnology, the many nanostructure has been constructed in recent years, such as the DNA polyhedral DNA, DNA dendrum, and DNA nanoflower, nanowire, and DNA nanodevice. This DNA nanostructure has been widely used in biosensor, bioimagers, and drug delivery, which provide a new technology for development of cancer diagnosis treatment platform. This report is mainly aimed at the recent problems in the field of the cancer and the treatment. Based on DNA technology, the highly sensitive detect problem and multifunctional drug delivery carriers have been developed. By assembling multiplied targeting aptamer with multiplied metal ion respective DNA ZAM, the smarter DNA ZAM problem was constructed to realize efficient capture and selective release of multiple types of the CTC using advantage of DNA applications and stranger. A nano device based on fluorescent RNA aptamer has been constructed for the low background imager of mRNA in a living cell. At the same time, the self-assembling DNA nanostructure was used as a carrier to construct a dual-model target tumor therapy systems, and further development and integrate intelligence response diagnosis and treatment the platform for tumor multi-models collaborative therapies and in situ images monitoring. The detector of the first work is captures and selective release of the multiplier type of circulation the tumor, the CTC. The detector of CTC is kind of the materials detected method in the liquid biopsy technologies, which can be used for the early diagnosis of tumors. Some systems has been reported for separations and enrichment of CTCs, such as magnetic isolate technologies, microfluidic technology, and flower cytometries. This is the captures. Another is a release. However, the still captures and counting CTCs has not provided the information to advance our understandings of biological of this real cell. The captures and analysis of the release of CTC can provide the important information of the primary tomb. However, some method developed to release CTCs a lack of selectivity, which indicated high requirement for captures and the release of the CTC. We established a platform to capture and selectively release multiplied CTC efficiency based on the smarter DNA ZAM problems. The substance was first modified with golden nanoparticles, which provide attached site for the capture element. This capture element we call the copper DNA ZAM, SCGC, SCGC, the 8C, like this, and mechanisms DNA ZAM and TDO5. was modified to capture the CM cell and Roma cell respectively. The addition of the copper ion as a cofactor catalyzed the cleave of the substance, the strand of the copper ion dependent DNA and release the CM cell. The addition of magnesium could also release the Roma cell. The gel's electrophoresis was conducted to indicate that successful cleave of DNA then powered by the metal ion like this. The successful modify of golden nanoparticles on the substance was characterized by the SEM imagers. This result of fluorescence imagers suggests that successful assembly of DNA problems on the substance. The imager shows that the platform has more than 19% of captures efficiency for each ETC. With the added of the metal ions, the corresponding CTC could be released with high efficiency like this. If we put the I, we can find some cell like this. Then we exploit the captures and the selective release of the multiplied CTCs. The result shows that successful captures, the captures of the two CTC like this, you can find, and selective release of specific CTC by adding of metal ion. That this MTT ethos shows that the concentration of copper and iron and magnesium ion has good compatibilities. More than the release of CTCs shows a good viabilities through the living and dead cell staining. Finally, we utilize the platform to capture and release the CTC in the stimulate the blood samples and the blood samples from the lung cancer patients. The result shows that our platform achieved captures and selective release of CTC in the real sample with high efficiency. Like this picture shows this result. The next work is the detections of tumor biomarker mRNA. The mRNA play an important role in life and are associated with many diseases such as cancer. Therefore, it is great significance to realize the highly sensitive images analysis of mRNA in cells. A variety of fluorescence images platform has been developed based on the HCR, the CHA, and TMSD. Like this is the toehold the mediated substance reactions. How like HCR, CHA, and TMSD. However, due to the short length, the low abundance, and high homology of mRNA, the selectivities and the sensitivities of detection method are highly required. Then we designed NIR infrared gate fluorescence on an aptamer-based nanodevice that could realize the self-delivery and controlled release of an entropine's driver RNA amplifier and no on the non-fluorescent diode in living cells for image RNA with high sensitivity and high signal to background region. We choose the TK mRNA as a target and MCF7 cell as a target cell. When the nano device was internalized into the MCF7 cell, the MG could release from the golden flower and the stimulation of the acid lysosomes environment, and this word in fluorescence of state. Meanwhile, the TN and FN could be driven away from the golden fly due to the high temperature generated upon the irrigator with a 606 nanometer laser, like this lasers, and the Empress driver cascade strand. This placement reactions could be initiated in the presence of target for the accurate images of intercellular low abundance mRNA. And from this, we can find that this is off state, this is on state. There is the fluorescence imager with a low background. This result of gel electrophoresis and fluorescence showed that RNA amplifier reaction was successful and had a good specific and signals amplifier. And the zeta potential and the source characterization shows that the nano device was successful, prepared, and MG diode could be released under the acid stimulation. Like from this picture, we can find this result. The result of fluorescence spectros is that this nano device were highly responsive and selectivity to the target, and could recognize the single base mismatch sequence. Moreover, it remains still stable after 10% BS treatment for the different time, indicate that the detection result has a good reliability. This image shows that the optimal incubation time was determined to be 4 hours, and only when the NR and the target co-existent is the nano device activate. Also, these images shows that the nano device can realize intercellular images with high sensitivity and low background, and shows excellent specific. Therefore, we believe that this NIR light gate amplification systems based on the fluorescence RNA aptamers will serve as a powerful tool for the precise delivery of images problems and sensitive intercellular RNA analysis. Another work I introduced, the door mode target the Tor therapies. as we know, DNA is widely used as the drug carrier, like I just told. From we use also the DNA structures to check and analysis the tumor. From this picture shows our work. The design principles as follows. First, the antisense DNA that can inhibit the expressions of the drug-resistant proteins was assembling onto the polymetric shell by one step of the assembly method. And at the same time, it was purified and modified with aptamer by PMSD reactions, modulate circulations, magnetic separations, the technology, followed by the loading the chem serpins drug like dogs. When the drug loading the DNA nanocarriers specific enter into the target cell. From this DNA assemblies, then into the cell, the anti-cell DNA binding the mRNA for inhibited expressions of drug-resistant proteins and increase the accumulation of DOX in the cell. They improved the chem therapies efficiently of the drug resistance tool. Okay, this is from this picture. Like I just take this Jun-Jie's experiences shows our the DNA assembly has constructions from this picture. This successful synthesis of the DNA and the DNA polycatenars. For this picture, we also find the magnetic separations can be used to the purified assembly the problems. Also, this picture that shows that there is no effects on the morphology size of these systems after the DOX loadings establishing excellent stability. Another picture shows the DNA and the polycatenars has excellently targeting recognized abilities and uptake efficiently of APTDPS. This is the systems by the target cells could be improved. Also, the DNA can inhibit the expressions of the drug resistance proteins and significantly in the increased cytotoxicities of DOX to the drug resistant cell. This also shows this is the involved anti-chaos efficient efficacy. Finally, we find that these systems and these nanocarriers has a good biocompatibilities and can effectively inhibit tumor growth with the actions of the anti-cells DNA and DOX. Okay, this is the final work I introduce the work briefly. We
please, could you summarize very quickly?
Okay. This is the final work like this. Also, we check the cancers therapies. This is also when the drug loading the nano machine, we can this machine can activate by the stimulated by the systems. System. I introduced the from this system the DNA. You can find this is the the TD and FD and D and the C has a different functions. The TD, the structure can loading the loading the dots. FD and the TD can loading the photo the photo the synthesis and the photo dynamics and the serpins also the C of the DNA structure. We can from use this DNA system we can to the therapies here. So the time is limited. I shows by the PPT. This also. The final is we can find this nanomachine can effectively accumulate at the tumor site and can activate it to achieve the improved images. Also, we also modify the distribution of gold element in various organs and tumor tissues. This is also we can find. This machine can achieve the real-time monitoring of the tool. Okay, finally, we do some work. We demonstrations the sensitive, the reliabilities of examining the function of the nucleic acid. And this separates a stronger advantage of the DNA and the polycatenous nanocarriers and the DNA gold, the nano machine in the multiplied, the co-divergence and the precise the cancer therapy in vivo. I thank you to the two students, and Qian Zhang and co-work. The Professor Jiang, Professor Zhang, and Professor Ming. Thank you very much.
So